Okie dokie geometry folks. So we are back with another video. This time we're talking about cylinders and cones. So we'll jump right into it. Again, our goal is to figure out their surface area and their volume. More specifically, their lateral. Oops. Sorry, I always forget to write in print sometimes. Specifically their lateral surface area. Okay, so real quick, a cylinder. And this one won't, probably won't take too long. A cylinder, you basically think of it as a circular prism. If I say that, at this point, we should have a good idea of what that means. All that means is that our base, which in this case would be two circles, there's one circle and maybe there's a circle here. And then I just connect those sides. Now this one's a little bit different because there are no vertices to connect, and so you could imagine just taking these two circles and then wrapping them around, similar to like a toilet paper roll. This one is, we would call this an oblique cylinder because the bases do not lie directly over each other. There are also oblique prisms. Those were the similar prisms that we saw in that last video, but I didn't bring it up because it wasn't quite relevant then. Okay, if that's an oblique cylinder, then what if the two bases are directly on top of each other, like your standard toilet paper roll or paper towel roll, say? We'll call that a right cylinder. A right cylinder. Again, when I'm measuring the height, we want to be careful here, is that you just measure the height. Oops, let's draw it here. Directly down from one base to the other. So again, it should be the perpendicular distance. So for this oblique cylinder, that would be the height right there, where this point down here on the bottom of the altitude is in the same plane as that bottom circle. In this case, the height of this right cylinder could just be found right there, or alternatively could be found right there. It would be the same height. Okay, and then again, because it's a prism, our base circles should have the same radii. Are there. Okay, so because it's a prism, we actually already know what the volume is. It'll work out exactly the same, even if it is a circular base. So the volume of a prism is equal to the area of the base times the height. Right? So that's the area of the base. It's just now, if the thing we're looking at is a circular prism or cylinder, what is the area of that base? Well, just remember, since the base is now a circle, I would need to know the radius. Assuming that we are given the radius, then the area of that base is just pi r squared. And then the height is still just the height. And that would be your volume of a cylinder. A slightly more interesting question would be, what would be the lateral area of a cylinder? So let's be clear about what this means. So, oops, we're going to talk about this for a right cylinder specifically today. So I'll draw my cylinder again. What would be the lateral area? So the lateral area would be the entire surface area minus the circles. So for us, it would be this blue area wrapped around, right? You can think of it as if you had a toilet paper roll and you had just enough toilet paper to wrap around it one time. How much toilet paper would you need? Here's how we can think about this. Is let's pretend that we took this cylinder, and let's pretend it's an actual paper towel roll, and just cut it straight down with a pair of scissors right there. So I'll take my pair of scissors, cut it right down there. Okay. If I then unwrap it, what shape are we going to get? Well, we should get a rectangle, I believe. And given this time, I'm sure you have a lot of toilet paper at home. Save one of those empty rolls and then try this out yourself. This should come out to be a rectangle. Now, let's assume we know, let's not forget that, let's assume we know the radius of this circle and we also know the height. Well, I think the height would still be right there. the question is, what is this side length now that we've unwrapped? Pay attention to where that came from. This side right here that I highlighted in blue, isn't that just the circle being unwrapped? And so really, this right here is the circumference of the base, which is in this case a circle. We know what that circumference is, which should be 2 times pi times r. And that gives us our lateral surface area, saying our lateral area, again, given the height of the cylinder and the radius, is simply equal to 2 pi r times h. Okay, so moving on now to cones, just like how a cylinder is basically a circular prism, a cone, you can think of it as a circular pyramid. Let's draw one right here. And there, you could also think of, you could also have non-circular pyramids, so such as elliptical pyramids or ovular pyramids. I wonder if that's the right term. Anyway, so a circular pyramid could be an example like this, and it leans over like that, pretend. That's maybe not the best example. Let's try to draw it a little better. There we go. This would be an example of an oblique cone, because our vertex, don't get right here, our vertex is not directly over the center of our base, which would be down there. And this would be an example of a right cone. Oops. Where the vertex is directly over the center. Let's pretend I drew that correctly. So in this case, again, their height would be drawn straight down. So the height of this cone on the left would actually be drawn right here. The base would have some radius r. And last part here is, don't forget that we have this thing called the slant height. Now this is interesting because in a right cone, the slant height is the same no matter where you draw it. So if I draw the slant height on this left side, that's L, the slant height. If I draw it from the vertex straight down to the circle, that's one length. If I draw it on the other side, it's going to be the same length. If I draw it on this oblique cone, if I draw, suppose, well, we can kind of see it already, this one on the left here, and this one on the right, you can tell that, let's call this one L1 and call this one L2. You can clearly see that L1 is bigger than L2. And so, at least for our class right here, when we calculate lateral surface area, we're not going to look at lateral surface area of an oblique cone. We're only going to look at right cones. That's a little messy. Let me fix that. Right cones. Okay? But still, we can talk about volume. So we know that the volume of a pyramid is equal to, you think of it as a prism, base area times the height, but then chop it, only take a third of it. That works the same way for a cone. And so if for a cone, I would start off with the prism that a cone would have come from would be a cylinder in this case, right? So it would be 1/3 the volume of a cylinder, which is 1/3, excuse me, pi r squared h. Ready? Here's the last question, and this one's actually, I think, the most interesting, is what is the lateral area of lateral surface area of a cone? So again, this would be if you had, a right cone. So this would be Well, I guess if you think of it as an ice cream cone with no ice cream in it, how much area, and so again, you're thinking of the area of the cone all the way wrapped around, but not the circle. And to actually do this, I want to show you a visual, so I'm going to ask you to step into my office with me right here.